I'm going to be talking about robotics, the challenges that construction face and how robotics can help with that. In particular, SAM, which is our semi-automated masonry system, our bricklaying robot that we've developed, which is really a robot to be used on site alongside the workers. So we've talked for the last few days about a number of the challenges that the industry is facing. You have labor shortages, you have people retiring. The age of your skilled workforce is getting older and older, they're retiring. How do we attract young people into the industry? These are all things that have been talked about in numerous presentations and discussions over the last few days. Not to mention you have construction that is, it's dangerous, it takes a toll on your body. Now I've talked to people that train in the masonry industry and they tell their people, you're trading your body for a paycheck. And when you think about the end of your work-life career as a field person who is lifting and placing bricks and blocks every single day, it takes a toll on your body. It takes a toll on your body at the end of a day. It takes a toll on your body at the end of a career. And if any of you have family members that were masons, you'll know because their bodies are broken down at the end of their career. So we have all these challenges in the industry that we looked at, and we feel that there's opportunities to help with that using robotics. In addition, you have increasing costs. We've also talked about this. The cost of construction continues to rise. So really, how do we become more efficient in construction? How do we help the workforce in ways that can extend their work-life careers, so they can attract new people into the industry? So how do we solve these problems? In masonry specifically, there was a downturn in 2008-9 where the amount of commercial masonry dropped, but there's growth coming back and there's growth projected to continue. But back in the downturn, the masonry industry lost a huge number of people. They retired, they left the industry because there wasn't the work. And so we have this growing gap between demand and labor. So as I am out there talking to masonry contractors, people in the industry, the common discussion is this skills gap. There's over 10 million new skilled workers needed by 2020. So how are we going to solve this? Well, recruitment. As I talk to the unions, the Bricklayers and Allied Craftworkers Union, as we work with them, one of their major topics is recruitment. They talk heavily about it. We hear about masonry companies, modest-sized masonry companies that actually hire recruiters to help find people because they're so desperate for people to come into the trades. And if you think about the future workforce of tomorrow, I like to show this slide. So this is FIRST. I don't know if has anyone heard of FIRST? Okay, so it's been out there for a while, and if you have kids, you've probably heard of it. And what it really is, it's a robotics program for people middle school, high school, and it's grown tremendously over the last 10 or so years that it's been out there. And it's an opportunity for kids to build robots. They develop software, they design hardware, they design electronics, they put it all together and they run the robots in this big competition, and it's crazy. They have these huge competitions and fill huge arenas, and these kids love it. They're super excited about it. It gets them engaged and that's what they, I think, expect in the future of the work that they want to do. So if construction is going to find people to come in the industry and work in the field and be out there, how do we attract higher talent people? How do we attract people like this, the future workforce of tomorrow, into the construction industry? Well, technology, as we've talked about, has been a big discussion, right? I mean, all the apps, all the software, everything that's out there. But I think it can be beyond that. So how do we solve these problems? I mean, BIM is a major discussion. In masonry, BIM is actually, they're quite behind with BIM. BIM for masonry, building information modeling, is a major objective for the masonry industry. But the thing that BIM starts to enable is better information upstream. I'm a manufacturing engineer, so I'm used to having full designs going into building an actual product. And as you look at BIM, what it can also start to enable is the use of robotics. So I'm going to shift gears a little bit and talk about robotics. As I said, I'm a manufacturing engineer. I spent most of my career doing automation, robotics, process engineering. I was in microelectronics. I was at General Motors. So I have a very different background. I wasn't really introduced into construction until about 10 years ago when I started down this road of this venture. And my partner, he's the construction guy, spent 40 plus years in the construction industry, and he saw, as a general contractor, and he saw how backwards construction can be sometimes, and how it's slow to adopt new technology, and how all the challenges that we've talked about. Well, when they first started implementing robotics 30 or however long ago it was, 30 plus years ago, I think some of the first attempts, they tried to over-automate things. They realized that didn't work. We need to engage the worker. And then I think as technology has evolved, you start to see scenes like this. You start to see scenes like the Tesla factory where they're able to really fully automate stuff. And that's after 30 plus years of trying to automate things. And they're able to do that because they have complete control of the inputs, the outputs, the process. They completely guard these robots off, so they're working all together. Well, if we think about construction, we don't really have any of that. You don't really have good control of your products coming in, your outputs. You have varying conditions, varying weather, varying people. So there's all these challenges with bringing robotics into construction. But the new age of robotics, where there's a lot of new investment, new technology coming out, is this idea of collaborative robotics. So how do we build robots that work better and more collaboratively with people? How do we build it so that you can leverage the human brain, the human eyesight, the human ability, and also put a robot in the mix to increase their productivity or reduce the heavy lifting of that person? Another example of that is the Vinci Robot. You've probably heard of this. This is really, I guess, an interesting example of a collaborative robot. Here you have this very highly skilled, highly trained, highly paid surgeon, and you put a robot in the mix, and what that robot can start to do is increase precision. They can help when they're working on longer surgeries. It can help in a lot of other ways besides replacing the surgeon. And that's really some of the fundamental concepts that we have thought about in our development of SAM. So SAM is our bricklaying robot, short for semi-automated mason. It's not fully automated. It's designed to work alongside the mason. So here's SAM in action. This is a picture from within the machine. And you can see it's pretty straightforward. The robot picks a brick, measures it, applies the mortar to it, and places it in the wall. And it's designed so that the mason sets up SAM. He leverages his skill and knowledge of the layout of the wall. He leverages his experience of how to blend the wall, how to set coursing and adjust coursing, to deal with steel variation, to deal with on-site variation, to deal with all of the challenges that come with building a beautiful masonry veneer on a building, on a commercial building. So it allows him the flexibility to do that. He sets SAM up, programs it, and then SAM runs. And it allows him to get consistent production, because when SAM runs, we know that SAM is laying bricks at about 300 bricks per hour, give or take, when it's running. So the question is, how do we keep it running and start to think a little bit more like a manufacturing process and leverage the people to handle the challenging aspects of construction, to handle the setup or the coordination and really prepare, but we give the bulk lifting, the bulk production to the robot and allow them to work alongside it. It can help reduce the safety impacts, because the amount of lifting that a mason has to do now is significantly reduced. I think they say that a mason typically lifts like a Ford truck worth of weight every few days or something like that. So it takes an incredible toll on your body. Well, if the robot can help with that, I think we can have a win. And it also enables interesting new concepts for building design. And this is something that we're just starting to explore and starting to touch on. So there's the utility of SAM, where it can help the workforce, help increase productivity, help make the contractor more money. But then there's the other side of it, where we start to get into digital design tied into robotic placement. Same thing happened with the CNC industry. It allowed, as machines came into CNC, into machining, as new computers and technology came into machining, they were able to do new and interesting design. Well, with building design, what our software can enable is a lot more of what you see here. Obviously, this type of interesting masonry design can be done today, but the actual construction of that is much more complicated. So what our technology can start to bring to the table is cost-effective ways to create more beautiful buildings, more interesting, intricate brick design as a standard. You can start to think about value engineering brick back into buildings, not taking it out. you can actually put it back in because it provides not only a great product, but it can also provide essentially a lower cost installation. And you can start to think about masonry as artwork. You can take a wall, you can take an individual section of a building, and you can treat each brick like a pixel on a screen, because now we have that capability from the design side and the placement side. So here's an example of a wall, pretty straightforward, pretty simple. We saw it's actually a pattern I think they use on Coors Field out in Denver. We saw it and we said, well, that's pretty cool. So we plugged it into our map software. In a matter of minutes, we designed the wall, and then we went downstairs in our shop and used Sam to lay the wall. It was over 1,000 bricks or something. We laid it up in a few hours, and that was kind of a neat example for us to just show what Sam can do. This is another example. This is our map software where we're able to put words on walls, put logos on walls, things like that. And we turn them into reality using the robot with increased efficiency. The robot can lay this brick wall as fast as it could lay a big flat brick wall. The speed is identical. And then we have an opportunity, so I'll give you a little case study here. We had an opportunity to work with a company, Potomac Valley Brick down in Maryland. They're a brick distributor, and they were putting up a new warehouse. And they had talked to us. They had a little bit left to do in the warehouse, and they said, we really want to see this robot in action. So they left a section of the building about 80 feet wide, 20-something feet tall. And they said, bring the robot in and let's run it. And we said, great. So there's about 4,000 utility bricks left in this wall. And as we looked at it, we said, well, we think we could probably, if we just run the robot straight, we can get it done in under 24 hours. Let's just run it continuous. They said, okay, no problem. So they agreed to do that. And we said, well, it's kind of a big flat wall. That's a little boring for us. What do you think about doing something interesting? So we took their logo, we put it in our brick mapping software, and we showed them some different variants of how their logo would look. We looked at how many cuts would be in that, the different patterns, gave them options, came up with the most efficient way to do it that actually looked cool, that they liked. So we ended up creating this 10-foot logo in the wall. Here's a little video of the job site. Great drone footage. But you can see on this building, it's a normal construction site. We work off of a mass climbing work platform. In this case, you have Hydromobile here. So the mass climbing work platform is typically used by the masons. It's set up just like they normally would. There's a small track section that adds to the front of the mass climber that bolts on to enable SAM. And then we have story poles where the masons set the story poles up. So in the first day we came in, we set the track up, the scaffold, the story poles, did some training with the masons, safety overview. And then the next day we started operation. They had 3 shifts of masons and laborers, and typically working with a machine you need 1 to 2 masons and you need a laborer. And we had technicians here supporting this job. But as you can see, it kind of seamlessly started to fit into the operation. The laborers liked working with it. They said, this is pretty easy, it doesn't yell at me. So they liked working with it. They would load it with bricks, they would load it with mortar. The masons would follow behind, they would strike joints, they inspected quality. And they made sure that the wall looked good. They had a good finish. And when it came to putting the logo in the wall, as the robot got to that point in the wall, the software would pop up and say, I need a 4-inch white brick loaded in chute 1. And the laborer would grab that brick and load it in chute 1, and the robot would put it in the wall and it would keep going. And so ultimately, it became part of normal production. And yet, they still got a great looking wall, they got a great logo, and it was a really cool case study for us. So if you kind of take that as a little example, traditional masonry, 3-man, 2-tender crew might have taken you 4 production days to get that wall done. Your labor cost per brick would be around $1.50, give or take. With the robot, we did it in under 24 hours with 3 masons and 3 tenders, basically, because they were spread. So almost the same number of people. In 24 hours, labor cost was about 41 cents per brick. We saved 3 days and $1 per brick. So it can be significant when you start thinking about commercial masonry installation. And this was a really small example. And this was also September, 216 bricks per hour. Like I said, right now we're running about 300 bricks per hour. So this technology will continue to evolve. And in addition to productivity, in addition to helping the crew, you start to get more data. When you think about robots in factories, they leverage data significantly. As a manufacturing engineer, we relied on the data constantly because that was how we got better. That data is, has been a huge discussion about how do we get more data out of the people. Well, with robots, it kind of comes for free. So we know, for example, that that brick right there in the wall is brick number 3,144. We also know that it was laid last August at 12:11 p.m. We know it's core 75. The temperature outside was 82 degrees, 89% humidity. We know the exact size of the brick that was placed. We know the mortar slump as it was applied to the brick. And we know our setup parameters and how we ran the process. And we know what who the mason was. Now, to be completely honest, I'm not exactly sure how this information will be used. But I do know as an engineer, I love this data because it helps us get better and it helps the contractors get better. In 10 years from now, 15 years from now, if there's a failure in this building facade, that mason contractor has a ton of data to show that they installed it correctly with the right mortar slump. They knew the exact dimensions of the brick. They knew the temperature outside, so they knew that that mortar didn't freeze during installation, and it may help their case. And then we can start to aggregate data. You can start to look at how you did on each job, if you're getting better over time, how your different crews are doing. By hour of the day, you can start to see your performance by hour of the day, by days of the week. So you can start to figure out, okay, what are my more efficient teams? What are my more efficient times? And you can start to react to that and change behaviors of yourself, your team, your construction process. So it's been interesting implementing a new technology in the construction industry, but we've been out there for a little over a year and a half with this SAM 100 system, this technology, and we've been on a number of jobs in a number of areas. But where we are today is this technology is now commercially available. We have a couple units sold. We have a distributor in the Midwest. We offer machines for sale. They're around $500,000, but we estimate that the payback on those, the ROI, is 1 to 3 years. It's a couple hundred days of operation. So it depends how many days you want to run it. How many hours can you run it? How many hours can you keep it running? And we also offer services. We offer a service where we come out, we run the machine, you get production. So we're starting to get the word out there. We're starting to get the technology out there. And I want to end on this one little story. We have a machine running outside of St. Louis right now. St. Louis is a very strong union town. I think a lot of the questions we get are, how do you interface with the unions? We've worked very closely with them because they recognize the need to attract young people in the industry, the aging workforce, all the struggles that they face, and they want to help the industry grow. They want to see more brick veneer. They want to see more block construction. And we think we can be part of that solution, part of helping them change the industry. So we're working on this job. Our distributor has a machine with one of their biggest customers, large union mason contractor out there outside of St. Louis. And we've been out there a couple weeks. And up until now, really over the last year and a half, most of the job sites that we've been on, our engineers have run the machines. And we've been able to improve it, improve the user interface, improve the technology, speed things up. Well, what's occurred in the time that we've been here, really in the last few days and I guess couple weeks, is that our technicians started running the machine on the job site, but we've also done some training. And over the course of the last week, there's been this interesting shift. I spoke with one of my engineering techs out on the site yesterday, and he said, I'm getting a little bored. He said he had his arms crossed all day because this transition has actually occurred where the mason contractor, the mason foreman is now running the machine. He's not afraid to pick up the tablet. He's not afraid to adjust the laser in the wall to give himself better quality. He's not afraid to adjust the mortar to get himself better quality. He's completely setting the story poles. He's setting the tabs. He's setting the coursing. He's doing everything. So we've seen this interesting shift occur. And so, like I said, it's a very interesting time right now because these people, this mason foreman who has spent his 30-plus year career with a trowel and a level is now fully integrated into technology. And he loves it because he's getting great production and his laborer loves it and the other mason that's working with it, they like it. And it's not to say everybody loves it. When we get on a job site, we definitely hear people say, you're taking my job. What are you doing here? You're taking my job. But I'll share one last story. So this same foreman who has started to run SAM, I overheard him the other day, and he was talking to one of his masons, and this mason was saying, what is this robot doing here? It's taking our job. And I heard the foreman tell his mason, this robot's not here to take our job. So we need all the people we can get. This robot is here to help improve our productivity, to help make us more money, to be more successful, we need to learn to work with the robots. It's not our enemy. And I thought that was a really cool story, that I didn't have to say it, that the foreman could say it for me. So we feel like this technology is here, it's now, and we have a pretty exciting couple years in front of us. Thank you.